Hi, this is a quick webinar from ZP, and this is our ZP Developer Zone webinar. I've got the date here as the 5th of May because this is when I was intending to put this out. We have gone a little bit early, but that said, let me go forward very quickly. So every week we like to answer technical questions that have come in during the week. So one of the technical questions that's come in during the week is about developing arterial blood gas analyzers, these ABGs. I will discuss it. The person interested in in pH, potassium, sodium, partial pressure, carbon dioxide, bicarbonate, lactate, and chloride. And I will touch upon those. It's probably worth just saying very quickly, I do have some technology in front of me today, and I will be doing some quick discussions around ABG using the technology that's in front of me at the moment. Second question that's come in today as well, or I'm going to cover today, is the rapid detection slash quantification of Resiniferatoxin, RTX. I will discuss this. This is a molecule that comes from the vanillinoid sort of group of molecules, because it has what we call the vanillin group on it, and I will discuss the detection and quantification of that, and I'll try to illustrate my answer to that actually doing a live demo as well. So I'll be using some material in a bit to try and illustrate the workflow for detecting this particular molecule, and I will be using the SenseIt-All hardware in a minute. I won't be going for accuracy on this today. I'll just be going for basically demonstrating what the workflow actually is. So that will be live demo when I'm doing, or rather a demo when I'm doing question number 2. Question number 3 is about connectors for EIS, electrochemical impedance spectroscopy. I just want to kind of warn or advise people on connectors, and I'll make some points about that as we go along. Just to say, we've got 3 upcoming webinars. There's 2 webinars next week, and there's another webinar in a couple of weeks' time from now. At ZP, a lot of what we do is talking about commercialization of electrochemical biosensors. So when I talk about the SenseIt-All, and as I say, I do have the SenseIt-All here. We're doing I would say, a more in-depth dive into the SenseIt-All on the 9th of May, which I think is approximately, it's 5 days from now, so it's probably about Thursday. That said, we will have a webinar. We do one in the morning, we do one in the afternoon. That helps to cover most of the global time zones. If you see a link pop up, by the way, during this webinar, I'll put the links underneath the YouTube when I put this onto YouTube. We are doing also a webinar on wearables. It will be on the 8th, or the day before. Again, there's 2 sessions. They are repeats of each other, and they're just really to allow people in different time zones to be able to attend. There won't actually be much discussion on wearables today, but this is a wearable technology that will be for discussion. This is the microneedle array that, for example, I will be discussing. This technology's had about £20 million spent on it so far, so it's a pretty cool, let's say, technology, and that will be discussed next week in the webinar. As I say, one in the morning and one in the afternoon. And then also, I appreciate there's a lot of people who are kind of interested in our technologies for academia. Especially our sort of screen printed electrodes. I think these are a really reproducible product, and that reproducibility is just something that I feel like, the lack of reproducibility in some of these screen printed electrodes that are otherwise on the academic market is really holding back academic research and really holding back commercialization. So we will be discussing that on the 21st of May. That said, so question number 1 is about developing arterial blood gas analyzer. The person is particularly interested in pH, potassium, sodium, partial pressure, carbon dioxide, bicarbonate, lactate, and chloride. Again, if you see a link pop up today, there will be a link underneath the YouTube video. I think there's a sort of, at ZP, there's really a choice. We do have these sensors on our website. The material that we're able to provide is on the website. So, you have to be able to kind of think that there's enough material there that you can actually go ahead with them. Because there's a second alternative, which I will also cover. As I say, I do have the SenseIt-All platform in front of me. In fact, some of things like potassium and glucose are on here. So for every sensor that ZP has, we are able to produce a QR code so that the sensor can actually be run on this particular meter. So I can understand with arterial blood gas analysis, you may want to do all those analytes in parallel. I would actually say that you should have a roadmap, and in the first instance, you should just be doing, let's say one analyte at a time until actually you have matured your understanding and matured your technology, and then you're kind of able to start bringing these multiple analytes together at the same time. So that said, we do have pH. We do have potassium, which is definitely one of the one of the sensors that you are interested in. We definitely have sodium on the website, and I did look around here, and a number of the data sheets are actually on the website. What we do have in the public domain is on there, and if you require anything else, then it's basically a deep, and it has to be funded collaboration with ZP. So the options are kind of go alone, and if you go alone, you can find the data sheets on the website, and now the data sheets on the website talk about the performance of our sensors. We're not discussing the performance of our sensors in somebody's particular analyte. So some people are interested in sweat, some people are interested in urine, some people are interested in saliva, some people are interested in blood, some people are interested in dialysis fluid. There's hundreds of applications for these different sensors, so everyone has to essentially get the sensor and characterize it in the particular matrix they're interested in. At ZP, we will only support the sensors when they're being used with the kind of with our electronics. Again, if you see a link pop up, don't worry, that link will put underneath the video as well. The thing at ZP is we're all about accelerating development. So when I see that somebody wants to develop a technology for doing like point of care analysis of arterial blood gas, then we do have our SensiAll platform. And I suppose I'm going to give you a quick heads up. If you've got your smart device, there are some QR codes that are popping up in a moment. I'd like you to scan those QR codes. So sort of be ready. If you've got an Android, it doesn't matter. If you've got an iPhone, it doesn't matter either. So we have this platform called SensiAll. As I say, I do have the SensiAll in front of me. We will be doing a couple of demonstrations in a minute of the SensiAll. I'll be doing those demonstrations fairly quickly because I just really want to show sort of utility. But what I do want to say is, if I just go here, the app that's going to drive this platform is available on the Google Play Store. So if you can scan that QR code, then you can install the app on your smartphone. That's if it's an Android, and if you've got an iOS phone or an Apple phone, then you can scan this QR code, and that will again install the app on your phone. When you install the app, it will ask you to create a username and password, so you basically get an account. At which point now you're in good shape because there's a whole series of QR codes about to jump up here. There's one for Chile, and so if you, for example, so the SensiAll platform is a multi-analyte platform to help both ZP and our clients bring new analytes or new analytics to the market. So you can see the utility of this because you can scan this for Chile, you can scan this QR code for ginger analysis, you can scan this QR code for pH, you can scan this QR code for nitrate, you can scan this code for total antioxidative capacity, you can scan this QR code for glucose. It was interesting because I knew that the people didn't ask for it, but obviously one of the biggest measurements of analytes in arterial blood is actually glucose. And then obviously potassium. I think potassium's super interesting at the moment. I think there's a lot of people interested in potassium for monitoring dialysis patients at home. So potassium's also on there. And then also we have this kind of, if there's an analyte that we don't have, then it can be developed. And we actually have this kind of generic QR code that allows people's brands, people's sensors and people's assays to be actually integrated into the platform as well. I said there were 3 webinars at the beginning of this webinar, and one of those webinars is the SensiAll webinar, and we'll probably go into this in a bit more detail there. so I might actually just change screens for a second and just kind of show you this a little bit. So I've got, I do have the device in front of me. I've got my phone here. So what my phone at the moment is actually saying that it's going to do a chili. So what I'll do is I'm just going to scan a different one. I'll scan the, now it wants to do nitrate, because I scanned the nitrate code. Now I'm going to scan a different one, and I will scan, which one's this one? That's ginger, so now it wants to do ginger. So you can see how easily I can go between these different analytes by actually just scanning a QR code. I'm actually going to just put it back to chili. Yeah, so chili's done. So this is now back in its, let's say, chili mode, and I'll be dealing with that shortly. So before I kind of progress on from this question, so the question here is, people want to develop technologies for doing blood gas analysis, arterial blood gas analysis. You can just essentially use the sensors on the website. If there's enough information for you to follow, then that's a good choice. If there's not enough information for you to follow, or you are confused, then it's probably the SensiAll platform. It's probably a better option for you. And sensors and the electronics, I will link to them underneath this video. But the whole model at Zimmer and Peacock is, we have sensors, we have electronics, we even have apps available. And you can see that through this kind of app, this last QR code here, where I go brand sensor assay, you can see that we're actually mindful that we want to support other people getting to market. But of course, in order to bring a medical diagnostic to market, you do have to be well funded. So we are looking for people who are well funded. With that said, let me go forward a little bit more. So question number 2 is actually analyzing both detecting and quantifying Resiniferatoxin, RTX. This is a kind of molecule that actually we quite like at ZP, and we're very, very, very experienced with what is called these vanilloids. They have this vanillyl group or vanillyl group, depending on your pronunciation, so RTX is a natural product. It comes from kind of cactus-like plants. They've got this they've got this latex in them, and this molecule can be extracted. It actually interacts. You get the sensation of heat when you eat the capsaicin. You're basically interacting with a receptor called TRPV1, and the molecules, these vanilloids, all have this kind of conserved vinyl group. So this is at the top left hand corner here. We have this Resiniferatoxin. It has this vinyl group or vanillyl group, and this group is actually conserved among all of these. We've got gingerol, we've got paradol, we've got curcumin. We have vinyl alcohol, we have got vanillin, vanillic acid, acetovanillin, vanillylamine, and also capsaicin at the end here. So what I want to do then is just do a little demonstration. I'm not going to be doing RTX because the assays that we do have in this group are actually ginger and capsaicin. But I do want to discuss RTX today. So RTX is we can definitely develop an assay for RTX on our SensiAll platform. The kind of concentrations that people are actually quite interested in are definitely within our analytical range, and I just want to do a quick sort of demonstration. So I will be doing this, I'll just do it live basically. So I will demonstrate that. Let me just remember what to do. So I've got the SensiAll. First thing I'm going to do is actually just bring the app back in. I know that screen's a little bit bright, but what I'll be doing is I'm going to be using the app now to make Bluetooth connection. I'll be using the app now to make a Bluetooth connection with that device there. So I'm just going to make a connection with it. Just doing that now, so it's made a Bluetooth connection, and it's now in Bluetooth connection with the device. Next thing I'm going to do is I just want to put some details into my app, because I want to tell my app sample ID, and where to save the data. Something that's not necessarily super clear, because I haven't actually discussed it, is every time we do a test, you get the result on the phone, and the result also goes to the cloud as well. So let me just put a quick word in here. I'm going to call this test. I'm going to call it toxin 1, text toxin 1. I'm going to put it under what's called a cluster, and I'm going to call that cluster demo. Right, so that is done. So I put those two details into the app now. What I'm going to now do is basically prepare the sample. So I'm going to use, I'm not looking for, yeah, I'm going to use this sample. It's going to be fairly viscous. Let me just flick that off like that. Just get that. Right, so I've got the sample out, good. I have got a scale here, so I'm just going to pull the scales in quickly. I just want to weigh out 0.1 grams of material, so let me just do that. I might not be super precise in doing this. I'm just going to do it fairly quickly. I just need a little bit more. I've got up to about, I want 0.1 and I'm at about 0.82, so I just need a bit more. Right, so I'm just going to have a quick lean in and see what that actually says. All right, so it's 0.106. So I'll take that. It will give me a you know, something like a 6% error, but I just want to kind of show the workflow fairly quickly. What I'm now going to do is I'm just going to take some buffer, and I'll just give myself a little shot of this particular buffer. Whoops a daisy. And I'm going to wash that weighing boat out with my buffer, and I'm going to get it then into this little vial. So let me do that fairly quickly. I'm going to do what's called a 1 in 10 dilution, because I know what the vanillal group, I know what the approximate I don't know what the concentration is, but this is what we know. This I'm expecting to be quite a low concentration of material. By the way, this app is quite clever, that if I get the dilution too high or too low, the app will actually tell me that is, let's say, a problem. And even if it does that, it does still save all the data anyway to the cloud. So that said, let me just go 1, 2, 3, 4, 5, 6, 7, 8, 9. I just want to lean in and read that balance a bit properly. Okay, not too bad. I got it at 1.02 grams. So you can appreciate that 9 parts of aqueous buffer, sort of essentially 0.9 mils of that, plus approximately 0.1 grams of the sample should bring me to essentially about 1 gram, which I wasn't that far off it, and I've done essentially a 1 in 10 dilution. What I'm going to do now is I will essentially mix it in the pan. I don't want to lose any of this material because it will just give me errors essentially, and I don't want them. And I'm going to put it into this little vial. I do have a vortexer in front of me. There's nothing fancy about this vortexer. It's just a vortexer that you can get on eBay. Obviously, depending on the sample, you can have a different sample prep, but this sample is quite viscous, but we are able to extract the material. By the way, it doesn't matter the kind of technology that we use at ZP. It's really good for rapid tests and rapid sample prep. A lot of analytical sciences require a lot of sample prep, and that's one of the beauties of this kind of technology, that actually it doesn't require a lot of sample prep. if you've watched other webinars from ZP, you'll see us pricking our finger, drawing blood, essentially live in the webinar. I just want to see how much material's left. You'll see us drawing blood in real time, let's say, and because even blood is is a very kind of messy little sample, but the kind of science that we use means that we don't need an awful lot of filtration and centrifugation necessarily of it to actually work. So at this point now, I've prepared the sample. It doesn't matter, it's cloudy, by the way. Electrochemistry or electroanalytical sciences don't really care about that. I do have a little vortexer over there. You'll probably hear it buzzing now. So I'm just shaking that up. That'll really help with the extraction. Because I basically want to get what's essentially an organic molecule out of any organic phases and into actual our buffer. So I just let that go now. Alright. It's not necessarily as worked up as I would necessarily want to do, but I wanted to do it in real time. I realised I probably need a clean, I don't really need a clean pipette. I'm just trying to demonstrate quite quickly, but I'll just put a clean pipette on. What I'm now going to do is I'm going to put 50 microliters onto the sensor, which is what I'm doing now. Right. Okay, done. Okay, that's the other nice thing about the kind of science that we do at ZP. So I'm in Bluetooth connection between my phone and the device. I'm going to hit go to assay. So now what's going to happen is, I'm just going to move that out of the way. The app is asking me what kind of dilution did I use. And I actually only used a 1 in 10 dilution, so that's completely fine. And I'll just start the measurement. The other thing I quite like about this kind of science that we do, this analytical science that we do, it is also lastly quite rapid. And I think actually that's the way we often try to develop our assays at ZP. We appreciate that if you're going to make a point of care, point of needs type assay, you can't really leave people hanging around. I mean, I was having a conversation this week with people who are doing infectious diseases. There, you want to kind of have the result there and then. So it's come back and it's told me that what the micromolar concentration is. So in this case it was 1048. It's told me the ppm. In this case it was 320, and because I was measuring capsaicin in this case, it's come back and told me that's 4800. So I think what I was trying to demonstrate here was really the ease of take the sample, weigh it out, add some buffer, centrifuge those two things, let's say, together. Put a small sample onto the sensor. We always build our assays so that they're nice and fast. I mean, you can't always get fast assays, but at least we actually do try to get them nice and fast as well. So what I want to do then is just finally, I'm just going to change screens for a second, because if I hit done, what it does say here, it says upload complete, and what that means is that actually the data has actually gone to the cloud. So this is the cloud. I can see my test toxin here. I can see time and date. So it tells me time and date, who did it. I get all that. I can see the raw signal up in the cloud, and then those results that I was talking about earlier on. I can see that I've got the 4,800 Scoville heat units. This is really good, because it basically gives you ultimate traceability, and also if you are, you have a strong science team, they can defend what the device is telling them, because actually they can also get back to the raw data as well. And the nice thing about it is that if you so wish, you can also share that data without emailing it or anything like that. Actually, you can have other people in your organization who you can then share this data with them as well. So what I will do then is, I had a final question that I wanted to go to today, so I'll just go there. So I just did a quick demo really showing how we would go about doing the workflow for RTX. Admittedly, this time I was actually doing capsaicin, but they're pretty when I say similar, people say, well, would actually think that they were quite dissimilar. But for a chemist, this conservation, this Van Al group is the key there, that they're actually similar in some manner. Question number 3 was actually about, this is a well-known potentiostat. It's not something that I support at ZP, but I've been talking to a client recently, and they're about to want to do some EIS on this instrument. And they are using a particular connector that will plug into there. And I just want to give people a heads up that these kind of connectors that you see, they can really, especially if you're doing EIS, these are not good connectors, especially for EIS. So if you're getting problems with your electrochemical impedance spectroscopy, just out of interest, and you're not getting repeatability, it actually can come from the connectors. So be careful about connectors. So question number 1, we're excellent at developing arterial blood gas analyzers. We do support people. Obviously at ZP, we're ISO 13485, so we're really interested in people who are actually going to market. But I think our Sensi-All platform, which I did do a demonstration of, obviously in this case, I was measuring capsaicin, but that Sensi-All platform does have some of the blood gas analytes already upon it. And so you can, it's not ready to be used with patients. That's not what it's intended to be, because actually, if we come up with a calibration, for example, for blood glucose, that doesn't mean that it's worked in urine. So you find out that for every application, there's actually still a bit of science to be done. But the Sensi-All platform is pretty mature. And then it's quite nice that actually it is a multi-analyte system. So you could see today that actually I could also measure natural products as well, and we'll be interested in extending it to RTX. And just a sort of heads up for people who are more sort of the more hardcore electrochemists out there. Be careful when you're doing EIS with some of these connectors. Those connectors, they're very ubiquitous in our sort of R&D fields, but actually they give quite a variable connection. I think they can really mess up your repeatability. So I think I want to say finally thank you. If you've got any questions to ZP, please don't hesitate to reach out to us. Okay, thanks very much.